This is Module 16, Section 10.1. In this module, we're going to look at rational exponents and radicals. We're going to start with radical expressions and some definitions that we're going to need to simplify radical expressions. The square root of a number is defined as the number b is said to be a square root of a if b squared equals a. So using this very simple definition, let's say you were asked to find the square root of 36. Now there are actually two numbers that when you square them give you the number that they're asking you about, which is 36. And those two numbers are 6 is actually a square root of 36 because, using the definition above, if you take 6 and you square it, as it says here, you get 6 squared is, of course, 6 times 6, which is 36, the number we're asking to find the square root of. But there's a second number as well that would actually give us 36 when we square it, and that number is negative 6. Again, using that same definition, because if you take negative 6 and you square that, which of course gives you negative 6 times negative 6, negative times negative is also a positive, and we still get a positive 36. So using the definition above, the square root of 36 could be either a positive 6 or a negative 6. Therefore, because there are actually two possible answers to that problem, to be more specific and only get one answer per problem, the square root, a special type of square root called the principal square root, has also been defined. The principal square root is the non-negative square root, and it's symbolized using the symbol or the radical symbol shown here in this video. Okay, so the rule is anytime you see the square root being asked with the square root symbol, by definition, it's the positive value that you want. And if you want the negative value, then what they're going to have to do is actually put a negative sign out in front of the square root symbol, and that will indicate that they want the negative possibility as opposed to the positive one. So, for example, if you were asked to find the square root of 36 using the square root symbol, that is an understood positive root. Now from above, we found that both positive 6 and negative 6 would work using the very basic definition, but using the symbol, it's the principal square root or the positive number that we want. And so using this type of symbolism, the square root of 36 is the positive answer only. Again, if we want the negative one, then we'll ask it like this. Find the negative of the square root of 36. Again, square root of 36 by definition, if you use that radical symbol, is the positive value. But if you take the negative of it, that is going to give you a final answer of negative 6 as shown. What happens when you try to take the square root of a negative number? For example, let's say you were asked to take the square root of negative 25. Well, that's a problem because notice that there is no number that when you square it gives you a negative 25. For example, if you take 5 times 5, which could be written as 5 squared is not equal to negative 25, it's equal to positive 25. And the same thing is true with negative 5. If you take negative 5, but you square it, negative times negative also is a positive value, and so there is no number that when you square it gives you a negative value. So therefore, there is no real number that is a solution when you try to take the square root of a negative number. It's important that you be able to recognize at least the following perfect squares for this module. Okay? And my recommendation, although you certainly have a calculator to support you, But it makes your life a lot easier as we get further into this module if you can recognize these first few perfect squares. So my recommendation is you do memorize these, even though you have a calculator to support you. 0 squared is 0, so 0 is a perfect square. 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square. 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and the last common one that I think it's important that you be able to recognize is probably 169. 169 is 13 squared. Now certainly there's infinite number of perfect squares, but once you get much larger than that, it's really too much work and less common that you'll see those. And so if you know the perfect squares from 0 squared to 13 squared, you'll probably have a very good start. All right, so let's look at some examples using those perfect squares and see some of the types of problems you might see to begin with. For example, let's say you were asked to find the square root of 49. Now, 49 is a perfect square. It's one of those on the list that we just looked at. Since the square root was asked using the square root symbol, it is the positive answer that we want. Okay? So the square root of 49 is a positive 7, and that is because, using the initial definition of square root, if you take that answer and you square it, which of course gives you 7 times 7, you get 49 back out, which was what we were trying to take the square root of initially. So the square root of 49 is a positive 7. Square root of 0, again, what you're asking yourself is what number multiplied by itself gives you 0? And the answer there is 0. 0 is a perfect square. Again, because 0 squared, which of course is 0 times 0, does give us our original number back out. 0 times 0 is 0. Let's look at the square root of 9/25. All right, now when you have a fraction, you can think of them individually. Okay, looking at the numerator first, is 9 a perfect square? And the answer is yes. The square root of 9 is 3, so that is going to be the numerator of our answer. Likewise, is 25 a perfect square? And the answer is yes. So the square root of 25 is 5, both positive because we're using that square root symbol. And so the square root of 9/25 is 3/5. Because if you take that answer, 3/5, and you square it, that of course in expanded form is 3/5 times 3/5. Do the math, multiply numerators and denominators. 3 times 3 is 9, 5 times 5 is 25. That was the original problem underneath our radical sign. All right, let's simplify the square root of 0.64. Now the only difference here is you have to think a little bit about where your decimal is going to go. You know that 64 is a perfect square, so 0.64 also should be a perfect square. And it is. Okay? The square root of 64 is 8, but the square root of 0.64 is 0.8. And if you check that, 0.8 squared is 0.8 times 0.8. And if you throw that into your calculator, 0.8 times 0.8 is 0.64, which was our original problem. All right, let's look at this one. Negative of the square root of x to the 4th. Now, think of radical signs as parentheses. You'll always do the radical piece first. So ignoring the negative, the square root of x to the 4th says what expression, when multiplied by itself or when squared, gives us x to the 4th. And the answer is x squared. But since there's a negative out in front of that radical sign, your next step is, after you find the square root of x to the 4th, you then have to take the negative of it, and so you would get negative. x squared. Okay? So to check that, let's just check the radical piece first. We've got x squared, and when we square it, we think we should get x to the fourth. So that would give us, if we expanded it out, x squared times x squared. You add your exponents. X to the 2 plus 2 power is x to the fourth. Now notice that there in the original problem was a negative out in front of it. Okay, and so we put the negative in there. So if we put a negative out here, that would translate then over here to give us a negative x to the fourth. Again, the radical is in there in the original problem as well. Okay, so for numbers that are not perfect squares, you can use a calculator to approximate their square roots. Now, if you look in your textbook, you'll notice that they do talk about how to approximate square roots without a calculator. That's certainly a good discussion just to understand the logic behind approximating roots, but since you have a calculator, I would only expect you to be able to use your calculator. So for example, if you were asked to approximate the square root of 3, notice that 3 is not a perfect square because 1 times 1 is 1, but 2 times 2 is 4. 3 stands between 1 and 4, and so 3 is not a perfect square. So if you put that into your calculator, you should find that to 3 decimals, that is approximately equal to 1.732. And I would expect you to have your calculator out and put that in and make sure you are getting the same value that I have listed out on that slide. Okay. So the next problem is the square root of 2/3. Okay. Again, neither 2 nor 3 are perfect squares. So this is a calculator problem. If you take 2 and divide it by 3, and then take the square root of that, your calculator should give you a decimal approximation. And I got, when I put that in my calculator, 0.816 to 3 decimals. All right, let's look at an approximation of the square root of 20. Okay? If you put that in your calculator, that's equal to approximately 4.472. rounding to the thousandths place. And finally, we've got negative of the square root of 0.5. Again, 5 is not a perfect square, and therefore 0.5 won't be a perfect square either. So if you put that in your calculator, okay, the square root of 0.5 is approximately 0.707, and then if you take the negative of that, you get negative 0.707. So finding roots can be extended to other roots as well, such as cubed roots. So let's talk a little bit of terminology here. So when you're reading in your textbook or I'm speaking about certain terms and I'm using the technical terms, we're all on the same page. When you're using any kind of root symbol, okay, it doesn't have to be a square root, it can be any kind of root. Whatever is written underneath the radical sign is referred to as the radicand. Okay? So for example, in this example that we're going to talk about next, our radicand in that cube root problem is our a value. Okay? The index or the root that you're taking, so this might be a 2 if it's square root, or a 3 if it's a cube root, or a 4 if it's a higher root, will be written out on the leg of that radical sign. And then the sign itself is referred to as the radical, or the radical sign. Okay, so the radicand is underneath the sign, and then the root or the index that you're taking, square root, cube root, is a smaller value that's listed out on the leg of that radical sign. So we talked about square root. Now let's talk about cube root, which means our index or our root is 3. The definition says the number b is said to be a cube root of a if b cubed equals a. And symbolically, as shown above, that is going to look like a 3 out on the leg of your radical sign with whatever you're taking the cube root of, in this case a, underneath the radical sign, or is your radicand. So find the cubed root of 8. That could be written with the radical symbolism if we wanted to, cube root of 8. Now what we're looking for then is a number that when we cube it, or when we multiply it by itself 3 times, we're going to get the original value, or the original radicand, back out. So we want to ask ourselves, what number multiplied by itself 3 times, or what number cubed, gives us a positive 8? And the answer to this problem is a positive 2. Because 2 cubed, which is 2 times 2 times 2, is a positive 8. And unlike square root, there's not going to be any confusion about whether we should use a positive or a negative value, because notice negative 2 does not work. Okay? Before, with square root, both positive and negative values worked, and so when we used the sign, we said by definition you want the positive value. Okay? But here, notice negative 2 doesn't work, because if you took negative 2 and cubed it, or took negative 2 and multiplied it by itself 3 times, 2 times 2 times 2 is still 8, but negative times negative times negative is negative, and that is not our original radicand. So notice that negative 2 does not work, so there is no confusion. There's only one possible answer, and it is a positive 2. And that's what's stated in this next paragraph. Note that there are not both a positive and a negative possibility for a cube root. Therefore, the principal cube root is not applicable. Also, note that you can take the cube root of a negative number. For example, if I asked you to find the cube root of negative 8, in symbolism that would look like this, the cube root of negative 8. What you're looking for is some number which when multiplied by itself 3 times, or when cubed, gives us a negative 8. That number would be negative 2. Because if you take negative 2 and you cube it, or if you take negative 2 and multiply it by itself 3 times, you do get a negative 8 back out, which was our original radicand. So the answer there is a negative 2. Okay, so let's look at some specific examples with cubed roots. Let's look at, to start, the cubed root of positive 27. We want to know what number, when multiplied by itself 3 times, gives us 27. And the answer to that is 3. And the reason for that, similar to square root, is because if you take 3 and you now cube it, since we're doing the cube root instead of the square root, if we take 3 and we cube it, or we take 3 and multiply it by itself 3 times, we do get a positive 27, which was our original radicand. So 3 does work. Remember, with cube root, you can take the cube root of negative numbers, unlike square root, which you couldn't. It was not a real number when we were trying to take square root of negative numbers. So is there a number which, when you multiply it by itself 3 times, gives you a negative 64? The answer to that is yes. It's negative 4, because negative 4 cubed, or negative 4 times negative 4 times negative 4, does equal negative 64. Looks good? That is the cubed root of negative 64. Let's look at the cubed root of x cubed. Is there a number, or a letter in this case, a variable, which when you multiply it by itself 3 times gives you x cubed? And the answer is yes. It's x, because x, when you cube it, or x when you multiply it by itself 3 times, does give you x cubed, which was our original radicand. Okay, how about the cubed root of 1/8? Now think about this in pieces. Let's start with the cube root of 1 is there a value which when multiplied by itself 3 times gives you 1? And the answer is yes, 1. Okay, because 1 cubed, which is 1 times 1 times 1, is originally 1. Okay, and what about 8? Is there a value which multiplied by itself 3 times gives us 8? The answer is yes, 2, because 2, when you cube it, gives you 2 times 2 times 2, which is 8, and therefore the cubed root of 1/8 is equal to 1/2, let's check that, is 1/2 cubed 1/8 if you expand it out. 1/2 times 1/2 times 1/2 is 1/8, and it looks good. Okay, one more. Let's look at the cubed root of -8x to the 9th. All right, we're going to think about this in pieces as well. The cubed root of 8, is there a number that when you cube it gives you -8? And the answer is yes, -2, because -2 times -2 times -2 is -8. Now, x to the 9th is a little trickier. Is there a value that when you cube it gives you x to the 9th? And the answer is yes. That would be x cubed. Now let's look at that. Okay, x cubed cubed is the same as x cubed times x cubed times x cubed. And remember, the rule for multiplication with like bases is you add the exponents. So 3 plus 3 is 6 plus another 3 is 9. That is x to the 9th. Or, using properties of exponents, another way you can think about it is powers raised to second powers multiply. So if you did it this way, 3 times 3 again is 9, you get x to the 9th either way. And it looks like -2x to the cube, I'm sorry, -2x cubed is the answer to that example. All right, so let's generalize for any root. We talked about square root, we talked about cubed root. Now let's generalize for any root we want to take. The formal definition says to find the nth root, the number b is said to be an nth root of a if b raised to the n is equal to a. And symbolically it's the same, except now, since we're just using a general root, we have an n out on the leg of that radical. So let's look at some examples and talk about that. Let's say to start off with, we decided to find the 4th root of 16. So what that says is we want a number which when multiplied by itself 4 times, or when raised to the 4th power, gives us 16. In this case, the only number that would satisfy that is 2, or in theory, -2. Because, notice that 2 to the 4th is 2 times 2 times 2 times 2, which is positive 16. Or if you took -2 and raised it to the 4th power, that would be -2 times -2 times -2 times -2. An even number of negative signs still gives us a positive 16. And so in theory, either of those numbers would work, just like square root. But just like with square root, if we use that radical sign to represent that particular nth root, then by definition, the square root symbol indicates you want the principal square root, which is always the positive possibility. So the 4th root of 16 is not 2 or -2, it's just positive 2 by definition. If we wanted the negative root, we would have to put the negative outside of the radical symbol. Okay? Do the radical piece first, that gives us a positive 2, and then apply the negative to get the -2 back out of it. So the 4th root of positive 16 is positive 2 only. Okay, let's look at the 5th root of -32. Is there a number multiplied by itself 5 times or raised to the 5th power that will give us negative 32? And the answer is yes. Negative 2 will satisfy those conditions because if you take negative 2 and raise it to the 5th power, or take negative 2 and multiply it by itself 5 times, which is what the 5th power means. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and an odd number of negative signs makes that a negative 32. That was the original problem. Notice that with the 5th root, a positive 2 is not a possibility, because positive 2 to the 5th is positive 32, and that was not the original problem. So this isn't even a possibility. So we don't need to worry about principal root for that particular problem. Okay, so let's look at this, the 6th root of negative 64. Is there a number that when multiplied by itself 6 times gives you a negative 64? And the answer to that is no, there isn't. Okay? Because when you have an even root or an even index, that means if you're talking about positive values, okay, a bunch of positive values will always give you a positive number. And if you're talking about negative numbers, an even number of negative numbers also gives you a positive value. So because this is an even root, it's a root of 6, you will never get a negative value out. And so this, like square root, gives you not a real number for the even root of a negative radicand. There's not a real number that is an answer to that. Let's look at the 4th root then of 81. Is there a number which when raised to the 4th power or multiplied by itself 4 times gives you 81? And the answer is yes. The answer is 3, because 3 raised to the 4th power, or 3 times 3 times 3 times 3, is a positive 81. And one more. Let's look at the 5th root of 243. Is there a number multiplied by itself 5 times that gives us 243? And the answer is yes, 3. Works there. If you put that in your calculator, 3 to the 5th power, or you can write it out in expanded form, does give you 243. So you might notice some trends there, and we're going to summarize those trends in this slide. There are some generalizations with nth roots that you need to know, and so we're going to look at those 5 generalizations here. First of all, if you are taking an even root, a square root, or a 4th root, or a 6th root, or an 8th root, then you assume the positive possibility, because there's really 2 possible answers, a positive or a negative possibility. By definition, if you're using a radical sign, you always assume the positive possibility. And on the previous slide, we talked about the 4th root of 16. In theory, there are 2 numbers that would make that true, both positive 2 and negative 2. But because there's 2 possibilities, we are going to assume that the radical sign itself indicates we want the positive possibility. If we want the negative possibility, then you have to throw the negative sign out in front. Also, if you have an even root, like square root or 4th root or 6th root or 8th root, then no negative radicands are allowed. For example, if I asked you to take the 4th root of negative 16, there is no number, no real number, that will allow you to find negative 16 by taking a number and raising it to the 4th power. So this is not a real number. And that's true for any even root, square root, 4th root, 6th root, 8th root, etc. One more thing with even roots. If you're taking an even root, then it turns out if you take the nth root of a to the n, the answer to that is always that base a after you take the absolute value. In other words, it's always positive. That's what taking the absolute value does, is turn everything positive. So for example, let's say you were asked to find the fourth root of -2 to the fourth power. Now if you just do the math and use orders of operation, remember we talked about radical signs as being like grouping symbols in terms of orders of operation. So you always want to do what's underneath the radical sign first. So if you did that, you'd get the fourth root of -2 to the fourth, which of course is -2 times -2 times -2 times -2 if you were to write it in expanded form. An even number of negative signs is going to give us then a positive 16. And the fourth root of positive 16 is a positive 2. Now notice that's a change in sign of what our a value was in the original problem. So if you think about this as a to the n, then what you do to get your answer is take whatever that a value is, you're going to take the absolute value of it, and the absolute value of -2 is positive 2. It's different if you're taking an odd root, though, of a similar problem. Let's say that you were asked to take the cube root, which is an odd root, of -2 now cubed. Notice here in both of these examples, we're talking about problems where the power underneath the radical sign matches the index. Okay? There's an n here and there's an n here. In other words, this is the fourth root and the fourth power. Same thing is true here. In this example, we're looking at the third root and the third power. So your power and your index match. If that's the case, then the answer here is always going to be whatever your a value is with the sign. Okay? So what this rule here says is our answer should be whatever a is, which is a -2. Let's actually do the math and see. So the cubed root of -2 cubed is the same as the cubed root of -2 times -2 times -2, which is the cubed root of -8 if you do that math. And the cubed root of -8 is -2. It's whatever a was in the original problem. So when you're taking an odd root, you do not take the absolute value of the a, you just take the a as given. And finally, if you're taking an odd root, so that would be cubed root or fifth root or seventh root or ninth root, both positive and negative radicands are okay. In other words, you can take the odd root of a negative number. You just can't take the even root of a negative number. And so to demonstrate that, you know that you can take the cube root of a positive 8. The answer there would be 2. You also could take the cube root of -8 because the answer there is -2. So negative radicands are okay as long as you have an odd root. It's just even roots that you're not allowed to take an even root of a negative radicand. Okay, final topic for section 10.1 is radical functions. Basic radical functions have the form f of x is equal to some root represented by n, so the nth root of x. For this module, you will only be asked to find a given function value for a radical function. So this isn't anything new. You've done this before. For example, if the problem said, given f of x equals the cubed root of 4x minus 2, and g of x is equal to the square root of x plus 5, find the following function values. So f of 2, remember this is always f or g of x. So the value that's in your parentheses is simply the number they want you to put in for x in that function. So f of 2 then would be the cube root of 4 times x, but now x is 2. So 4 times 2 minus 2, which would be the cubed root of 8 minus 2, which is the cubed root of 6. And notice the problem says to use a calculator to find approximations. And so if you found the cube root of 6 on your calculator, that would be equal to approximately 1.817 to the thousandths decimal. All right, f of negative 3 simply means to place negative 3 in for x in your f function. So again, we've got the cubed root of 4 times negative 3 minus 2, which is equal to the cubed root of negative 12 minus 2, which is equal to the cubed root of negative 14. Now, can you take a cube root of a negative number? And the answer is yes, because a cube, or a 3, is odd. You can take odd roots of negative numbers, you just can't take even roots. So that also is a calculator problem, because 14 is not a perfect cube. The cube root of negative 14 is equal to approximately negative 2.410 if you round to the nearest thousandths. Okay, g of 0, now we're going to look at our other function. We're looking at our g of x function. G of 0 simply says to put 0 in for x in your function. So now we're taking the square root of 0 plus 5, which is equal to the square root of 5, and that is a calculator problem. The square root of 5 is approximately equal to 2.236. And g of negative 7 simply says look at the g function again and put negative 7 in for x. So here we're going to take this and we're going to get now negative 7 plus 5, which is the square root of negative 2. Now, square root is an even root. Okay, remember that anytime there is not a number written out on that index, it's an understood 2. Okay, so square root is an understood 2 out on your root. Even root, 2 is an even number. Can you take an even root of a negative number? And the answer is no, not if you want a real number. Okay, this is not a real number. All right, so this is the end of Module 16, Section 10.1 material. You should now complete the homework for Module 16, Section 10.1 found in my math lab. And when you have successfully completed the above homework, proceed to the video for Module 16, Section 10.2.